Okay, so this is my linear regression analysis. So I use a data set that is the data set from teachers in St. Louis Public School in Michigan. And so an objective that I made is investigating the relationship between the years employed and the salary of the teacher. So this is a description of the data. It's the teacher salaries from 2009 to 2010 for 71 teachers employed at St. Louis Public School in Michigan. And so what I'm going to be comparing is the years, which is the number of years employed by the school district, and the total, which is the total annual salary of the teacher. It is the sum of salary, the base salary, the FICA, and the retirements in US dollar. And so this is just to check the data first. First of all, I checked if there's any NA in the data, and it seems like there's no NA. And there's the ID, the years, the three compensation, and the total. And then there's also a section for degree. And FTE is basically like the status, whether the teacher is full-time or part-time. So here, first I visualize the data. First I check the correlation to see the correlation R, if there's any correlation between if there's any linear correlation between the two, and it seems like there is some sort of linear correlation. So I visualize the data, and I saw a clear increasing trend here, and I also saw there is an outlier right here. And I also checked the degree. So I noticed that people with an MA often have their salary is a little more than people with just a bachelor degree. So I also use a box plot to visualize and see if there's any outliers. And so there's one right here which confirms my prediction from before. And I also see the lower fence is a little longer, and this suggests that the data at first it might increase linearly, but then it starts to stagnate and starts to level. And so first I split the data into 90% training and 10% testing. The reason for this is because I want to see if I am able to produce a more accurate model. So I create the model, and I use these 5 factors to verify to check the linear regression model. So first is linearity. I made the fitted versus residuals graph, and I saw a certain pattern. So first it's underestimates, then it overestimates, and then it underestimates the errors. So this suggests that there is more than just a linear relationship. So after that, I check the independence. So since each data point is a person, a teacher, they are not related to each other, so they are independent of each other. And then for homozygosity, since there is a pattern, which is kind of like a upside down parabola, I think that this data set is not homozygosity, but it is heterozygosity. And then I use a QQ plot to check the normality of the residual. and I do see that it does somewhat follows the line, but then at the end it starts to steer off. Um, this indicates that the sample quantiles is lesser than the theoretical quantiles, suggesting that the sample isn't distributing normally and seems to focus more on the top end. So it means that the teacher's salary does not follow normal distribution, since there is a concentration of teacher with high salary near the end, and also there's the outlier near the bottom, which could greatly influencing this model later on. So now I want to check the influential observation, so any data points that might affect the model the most. So I use the studentized residuals versus the fitted values graph, and so this is like the standard deviations of the residuals, and I noticed that there's a potential outliers right here, but I want to do some more testing, so I did the graph with the Cook distance, and now I can clearly see that there's two outliers. Yeah, so these two right here. So this shows which 2 points they are, which is this one and this one. This bottom one, after a little checking, I noticed that this person is actually doing part-time, so their salary is a little lesser than other people, so that's why this point is so low. And this is like the longest working person, so their salary doesn't increase much, so it might potentially affect the data. So first I did the statistical summary of including these two outliers, and here's the regression line, the prediction line. I noticed that the R square is really high. It's 76.7%. So this means that the model can and somewhat a good indicator for predicting the teacher salary. The p-value is almost 0, so this means that by chance the slope cannot be this steep, so there is a this suggests that the slope for this line is not possible to occur by any chance, meaning that the years of experience by a teacher is directly responsible for their salary. And then the F statistics say that the F statistic, which is 200.7, it says that this model has improved the chance of predicting the salary significantly instead of just using the means of the salary. And I also did the RMSE and MAE. So the residuals can vary by around $6,227 dollars. So this means that the teacher salary that is estimated with this model will have either $6,227 more or less in salary. Afterward, I try and remove the two outliers with this line right here. I draw the scatter plots again. I made a new regression line, and I visualize the data. So this is the regression model after removing the outliers. And so I did the model summary again, and the R squared improved from 76 to 83, so it's being more accurate. The F statistic has increased, which also support the ability to predict data, the model ability to predict data more accurately, and the standard errors also shrink. So in summary, to answer the objectives of the analysis, there is a correlation between the total computation of teacher with their years of experience, and the relationship is directly proportional. And through the fitted versus residual graph, the data seems to slightly steer off from the linear trend and stagnated after the teacher experience is above 13 years. So this salary kind of stop increase after 13 years of experience. Um, the regression model that I made is able to accurately predict around more than 80% of the data with an estimated error of around 6,000 USD dollar. And then there's also two outliers that affects the data sets, which is the longest working person and the part-time person. And then also teacher with an MA often earn a little bit more than teachers with just a BA. So yeah, that's my analysis.